Welcome students. We are discussing this chapter matrix and we already completed up to skew symmetric and symmetric matrix. So today we will talk about invertible matrices. So let's start with this topic with its definition. What is the definition? If A is a square matrix of order M and if there exists another square matrix B of same order M such that AB equal to B is identity, then B is called the inverse of A and it is denoted by A inverse, and in this case A is said to be invertible. Now let's understand the meaning of this definition. So primary condition for finding this inverse of matrix, that is, it will be a square matrix. We have to take a square matrix of order M, means M by M order square matrix, and if there exists another matrix, that is square matrix again B of same order, and then if it will follow this condition, that is AB equal to B equal to identity, then B is called the inverse of A and it is denoted by A inverse. Okay, and in this case A is called invertible. You know, invertible and inverse, a similar type of thing. So here the primary condition is square matrix, and the another matrix B we are choosing, it also square and same order, and if A and B satisfy this condition, we will call this B is the inverse of A. So let's check this definition by an example. Here I'm taking this A is 2, 3, 1, 2 and B is 2, minus 3, minus 1, 2. These two matrices I have taken. So primary condition is a square matrix. Both are square matrix of same order, 2 by 2. Now we need to check this condition is hold or not. This is condition AB is identity or not, and BA is also identity or not. If we can show that they are identity, we can say this B is the inverse of A. So what is AB? 2, 3, 1, 2 and 2 minus 3 minus 1, 2. Just multiply these two matrices and write down the matrix after multiplication. It is 1, 0, 0, 1. I'm not explaining the calculation for multiplication since you know how to multiply two matrices, row with column. Since explaining the operation, explaining this calculation again and again, it's quite boring. So AB is identity. So first one proved. Now let's check the second one. BA should be identity. So B into A, 2 minus 3 minus 1, 2, 2, 3, 1, 2. Just multiply it row with column. You will find this is also I. That is the identity matrix or U-date matrix. So 1, 0, 0, 1. We proved the second one also. So we can show this AB is BA is identity. Correct? So if it is identity, so we can say that B is the inverse of A and represented by A inverse. And in a similar manner, we can also say that A is the inverse of B, where it is represented by B inverse. Same, they are the inverse of each other. But look at here. These two matrices are given here. You just need to check. This is the condition for checking these two matrices are inverse of each other or not. But one matrix A is given. How you will find its inverse? Now let's check how to find this inverse. For finding the inverse of a matrix, we will follow these two rules. First is elementary operation. And second is by this formula, A inverse equal to 1 upon determinant A into adjoint A. Okay, after knowing what is determinant, we will apply this one. So we will talk about this formula later. But for now, let's talk about this one, elementary operation. Now for applying elementary operation, you need to know what is elementary operation is. So what is elementary operation on a matrix? So the elementary operation on a matrix has three types. First type is interchange of two rows or column of the matrix A, and this is the mathematical representation of this interchange row or column. Either you can change the row with row or column with column. That is, you can change the row 1 with row 2 or you can change the column 1 with column 2. Right? Now the second type, multiplication of row or column by a non-zero scalar. So this is the mathematical expression for this type, multiplication of a row or a column by a non-zero scalar. Now what you have to do, if this 2 by 2 matrix is given 2 3 1 0, now I am taking this operation r1 dash is equal to or replaced by k into r1. So first row is replaced by k into r1. So after this operation we can write this is 2k 3k and 1 0. This second row will remain same, only we will change the first row. This is 2k and 3k. We have to multiply the k with each and every element present in this row, and same thing happen for column. This is the mathematical representation, that is I am replacing the jth column with k into the previous jth column. So this is the second one. And the third one is addition of a scalar multiple of one row or column to another row or column. And this is the representation, that is the mathematical representation of this third type. So let's understand this one also with an example. Take the same example, 2 3 1 0, this matrix, and I am applying this operation rj plus k ri. So r2 plus k r1, apply it. So after applying it, you will find this matrix is given by, since r2 plus we will apply on r2 and r1 remain same, so this is remain same, 2k 3k, apply in r2. So r2 plus k r1, that is 1 plus 2k and 0 plus 2k. This is the third type. Now if you notice here, we are applying this operation on row or column, right? Either we can apply it in row or we can apply it column, but not together. We will apply it separately, either row or column. So when we are applying this operation on row, we will call this is elementary row operation, and if we are applying on a column, we will call this is elementary column operation. So this is the process or the types of elementary operation. How many types are there, and this how to check this, how to follow the elementary operation. What are the types? Now how to apply this one on a matrix for finding the inverse. So here I am taking one example for showing this two process, that is row elementary and column elementary operation. Both the operation we will apply on this matrix A, and we will check that how to find the inverse of this matrix A. The process of finding inverse and the process of applying this elementary operation on a matrix for finding inverse. So firstly, check this row operation. Now A is given, so I can easily write A is equal to identity into A. Since identity, if we multiply any matrix with identity, it will remain same. Now for what is the condition? AB is equal to BA is equal to identity. So look here, I am taking this portion, BA is equal to identity. What I have taken here? I have taken here A is equal to I into A. But what we have to show? If we want to find this inverse, we have to find this value of B. That is, we have to convert this equation into I is equal to B into A. If we can convert this one, then we can say this B is the inverse of A. Now why we're choosing this part, not choosing this part, and by showing one part I am telling this is the inverse, that we will discuss later. But first know the process. First learn the process. So if I find this B, then we can say this B inverse, B is the inverse of A. Now we don't know this matrix B, but we know this matrix A and matrix I of 2 by 2. A is given and I is 1 0 0 1. So if I convert this matrix A to the identity 1 0 0 1, and same operation we will apply on this I, we will find this matrix B and A will remain unchanged. So this is the process of finding the inverse. That is, we have to change this matrix A into identity, and for changing it to identity, whatever application or whatever operation, row operation you are using, you have to use the same operation here. This is the process. So firstly, write down the matrix A is equal to I into A. Since I'm not changing this A, so no operation will apply on this. We will apply no operation on this A. This A will remain unchanged. Okay. Now, what we have to do, I have to make this element 1 1. No problem. I have to make this element 0 and this element also 0 and this element 1. Okay. So my first work is this matrix. We have 1 2 2 minus 1. First we will make this 1 1 2 0 minus 1. Okay. So for making this element 0, what I have to do? 2 minus 2. If we put 2 minus 2, that will be 0. So 2 minus 2 means, if we write this operation, R2 is replaced by R2 minus 2R1. So let us apply this one. So if we apply this operation on this matrix A, so first row will remain unchanged, and in the second row we will changing this row 2 minus 2 into row 1, that is 1, and row 2 minus 2 into row 1. So now if we simplify it, you will find this is 1 2 and 2 minus 2 0 and minus 1 minus 4 minus 5. Okay, and same operation we have to apply on this identity matrix. That is, first row will remain unchanged and second row, that is row 2 minus 2 into row 1, row 2 minus 2 into row 1, and that will come 1 0 minus 2 1. Here it is. Okay, just first understand it, how to apply the process or this operation. Now our next work is taking this leading element, making this leading element 1. Now I have this matrix. Now I have to make it 1 2 0 1. Now how could I make this one? 1 minus 5 is given here. So if we multiply this, minus 1 upon 5. So we will get this one 1 2 0 1, and same operation we will apply in this matrix also, that is 1 0 minus 2 into minus 1 upon 5, and the second element 1 into minus 1 upon 5. So that will come 1 0 2 by 5 minus 1 by 5. So here it is. Okay. Now I have to make this matrix in this form 1 0 0 1. For that we need to, what do we have to do? We have to row operation we have to use. So 2 minus 2 is 0. So if we multiply this row 2 and then subtract from row 1, then we can easily find this 1 0 0 1. Now same thing we have to apply in this matrix also. So apply this one. This R1 dash is equal to replaced by this R1 minus 2 R2. So if we apply this one, we will find the first row is given by 1 upon 5, 2 upon 5, 2 upon 5 minus 1 upon 5. Just apply this one. Let me show you. 1 0 2 5 2 by 5 minus 1 upon 5. This matrix is given. You have to apply this operation R1 minus 2 R2. So R1 is 1 minus 2 into R2. R1 is 0 minus 2 into R2. And this row will remain same. So this will be 1 minus 4 upon 5. This is 1 upon 5. Minus 2 into minus 1 upon 5. 2 upon 5. This is 2 upon 5 and minus 1 upon 5. So this is your inverse of A. Clear? How to find this inverse of A? So apply the operation one by one. Do it in calculation. You can do it in rough. Do it step by step. If it will take time, then give it time. Give it some time. You will know how to apply or how to use this row elementary process. Now here I am using this 3 operation. You can use different operation also. Okay, for making this element 0. If you want to apply another operation, you can. But most of the time, the operation mostly same. Sometime it will be different, but mostly the same operation we need to follow. So next, we will use this column elementary operation on this matrix A. So apply this column elementary operation. First, we can write this A is equal to A into I. Again, same thing. Why we are choosing this portion, not another one. I will discuss this one later. But for now, learn the process of finding the inverse. This part is very interesting part of this matrix chapter for finding inverse. Whenever you will learn finding this inverse by this formula, that is A inverse equal to 1 upon determinant A into adjoint A, this is also interesting part. So A is equal to A into I. So we have to make this one identity equal to A into B. So means that A you have to make I. So put the value 1 2 2 minus 1. A is equal to A into I. And this A, we will not disturb this A. It will remain unchanged. Now we have to use the column operation on this 2 matrix. This one and this one. Firstly, we are using change this column 2 by column 1 minus 2. Column 2 minus 2 column 1. Same type of operation you followed for row. Same type of operation I am taking for column. Replace it. You will find this matrix. Again, replace the second column, that means this column and this column, by multiplying this minus 1 upon 5. So we will find this leading element is 1. Okay, same type of operation. Now we need to use this, we need to make this one, this 2 is 0, right? That means we need to make changes on column 1. So we will apply the operation of column in column 1. The same type of operation will apply here, and you will find 1 0 0 1, and this inverse is given by 1 upon 5, 2 upon 5, 2 upon 5 minus 1 upon 5. These two are same. I'm not describing this column elementary operation since the same explanation for this column elementary operation also. So I'm not expressing it again and again, explaining it again and again. So this is the inverse by this column elementary operation. So choose any of them and follow this one. Don't choose this. Somewhere you are choosing row, somewhere you are choosing. If it is not mentioned that you have to follow the row or column operation, just choose any of them and solve this question. And if it is mentioned, that time you will use it. Know the process. Definitely you have to know the process. Sometimes may the question in this question they mention that is you have to use the row elementary or you have to use the column elementary. So learn the process, but choose one of them and solve the problems. So let us take another problem. Find the inverse of a matrix 2 1 1 1. 2 by 2 matrix is given using the elementary operation. I'm choosing this row operation. A is equal to identity into A. I'm choosing the row operation. So our first work is write down the A 2 1 1 1 and the I 1 0 0 1 into A. So our next work, this element is 2. I have to make it 2 1 1 1. My first work or our first work is to make this one 1 1 and this element 1, and there will be different element, maybe some element A. I'm taking any value will come. I'm taking here A. So firstly we have to make this element 1 and leave this other element. So for making this element 1, if we subtract this row 1, row 2 from row 1, then we easily 2 minus 1 is 1. So apply this one. So row this minus 1, 1 minus 1, and just a minute. Apply this operation, that is 2 minus 1, 1 minus 1, and then 1 1. The row 2 will remain unchanged. So this is 1 0 1 1. Now 1 0. First row is completed. We don't need to apply any operation on the first row. Since we need to find 1 0 0 1, 1 0 already we get. So apply the same operation on this identity 1 0 0 1. We need to subtract this 1 minus 0 and 0 minus 1, and this row will remain unchanged. So 1 minus 1 0 1. Here it is. Now here it is 1, so no change. Now you have to make this one 0. So make this one 0. Apply this operation, that is R2 is R2 minus R1. Here is your R2. 1 0 1 1. You need to apply this is 1 0 1 minus 1. This row minus this row. 1 minus 0. So you will find 1 0 0 1. And same operation apply on it. You will find this one 1 minus 1 and 0 minus 1, 1 minus of minus 1. That means 2. So 1 minus 1 minus 1, 2. So I got the identity here, and this is the matrix B or A inverse and into A. So what is the inverse? Inverse is 1 minus 1 minus 1, 2. Okay, so this finding the inverse is very easy. Just you have to apply, you have to use your brain for this, choosing this operation. That it will be a shorter way but easiest way. You need to choose the operation such a way you will easily find you will easily find this identity matrix, and less complicated operation choose. Choose the less complicated. Don't choose any complicated operation. So solve another problem. Here the matrix is given 2, 3, 5, 7. 2 by 2 matrix, square matrix. Here also I am using the row operation. A is equal to I into A. Now put this A 2, 3, 5, 7 and I 1, 0, 0, 1 A. So my first work is making this element 2, 3, 5, 7. I have to convert this one. This first element should be 1. And since I am using the operation in row 1, so row 2 will be same. So what I have to do, if I divided this row 1 by 2, we will find 1. So this will be 3 by 2. Divide this row 1 by 2. And for the identity matrix, 1, 0, 0, 1. Divide this one by 2, that is half, 0, and this will be 0, 1. Now next operation. Next our aim is to make this one, this element 0, this 5. So I have to multiply the row 1 with 5, then subtract from row 2. This operation you can use. So if we use this one, so first one remain unchanged. For the second one, 5 minus 5 into 1 and 7 minus 5 into 3 by 2. So it will come 1, 3 by 2. This is 0 and this is 14 minus 15, that is minus half. Same operation apply here in this matrix. So you will find this first row will remain unchanged. Apply this operation on the second row, that is 0 minus 5 by 2, 5 into half, and this one will be 1 minus 5 into 0, or we can write 0. So that will be half, 0 minus 5 upon 2 and 1, not 0, 1. Now our next work is to make this element 1. Now if we multiply this element with minus 2, it will be 1. So multiply the row 2 with minus 2. So what will you have? Since I'm operating on row 2, row 1 will same. Just multiply it. 0 into minus 2, 0, and minus half into minus 2, that is 1. And this will change into half, 0. This will be minus 2, then it will be 5. And if it is minus 2, that will be minus 2 here. So half, 0, 5, minus 2. Next work is to make this element 0. This is 3 by 2, 0. So what you have to use? You have to use this R1 change by R1 minus 3 by 2, R2. Correct this one. This will be R2, not R1. So apply this one. So 1 minus 3 by 2 into 0, 1. Now 3 by 2 minus 1 into 3 by 2. So that will be 0. I'm writing it directly. So 0, 1. Okay. And if we apply the same operation on it, so half minus 5 into 3 by 2, that is minus 7, and 0 minus of 3 by 2. That is 2 to cancel, and that will come minus minus plus, that will come 3. So identity is equal to some matrix into A. So this is your inverse. So here A inverse is given by minus 7, 3, 5, minus 2. So solve some problems from 3.4 of your NCERT book. There are some 2 by 2 matrix are given. Just take any matrix and find their inverse. So any problem or any doubt is there, you're free to ask. Thank you.